Okay, so in this video here, I'm going to walk you through 4 problems from Khan Academy on compound inequalities. So compound inequalities can be very easy, but also very challenging. It really depends upon the problem. And so that's kind of one of the tricky things is that you don't know what to expect with compound inequalities. I'm hoping that we get a good variety of problems here on Khan Academy. All right, let's go ahead and take a look at the first problem. So we have this concept of compound. It means that you have more than one inequality going on at the same time. So you have 2 different inequalities that are setting restrictions upon the situation. In this case, we have this inequality or this inequality. So we're looking for a solution that works here or it works here. It doesn't have to work in both inequalities. It only has to work in one of them. So that's the main difference between the word or the word and. Think of it as like you go to, I'll just say McDonald's, and let's say you can't go to McDonald's, but a friend's going to McDonald's. And you say, oh, well, can you get me a cheeseburger or a McChicken? They don't have to get you both. They just need to get you one of those items, and that would meet your request. If you said, get me a cheeseburger and a McChicken, then in that case, you'd be expecting your friend to come back with both of those items. So in this situation, what you want to do is just solve both inequalities. So if I solve this first inequality, which I'll draw over here, so we have 5x minus 19 is less than or equal to 1. On this first inequality, I'm just going to go ahead and solve it. So I'd add 19 to both sides. And my writing here with my mouse is not that great, but I'm doing the best I can, I promise you that. 5x is less than or equal to 20. And get x by itself, I'll divide both sides by 5, and x is less than or equal to 4. That's one of our solutions. We're going to do the same thing for this other inequality as well. Negative 4x plus 3 is less than negative 6. Subtract 3 from both sides. We get negative 4x is less than negative 9. We want to get x all by itself, so we divide both sides by negative 4. Getting us x by itself, we have 1x. Since we divided by a negative, our inequality flips. And now we have on this side positive 9/4. So we're saying our solution is right here. It's x has to be less than or equal to 4, or x has to be greater than 9/4. For all of these problems, there is some possibilities here. You could end up with all values of x being solutions. You could end up with no solutions, or you could end up with something else. And so to analyze these, I always find it best to plot this on a number line and just real quickly kind of plot your 2 points. You don't even need anything else other than just 2 tick marks. And as long as you understand the general concept of a number line, that going to the left is negative and it's smaller, going to the right is positive and it's bigger. That's really all you need to plot here. You don't need to plot every little thing for x. All right. So we have this number line representing x, and we have one of these at 9/4. So I'll just say this is 0, and this may not be accurate, but 9/4 is a little bit bigger than 2. So this is 1, 2. All right, let's just say this is 9/4. And it looks like we have one at 4. So I'll just put 4 over here. All right. It doesn't matter to me too much about the accuracy of this. This is just a visual to kind of make sense of the problem in our head. We know that x has to be greater than 9/4. Greater than, so that's going to be an open circle, and it's greater than, so it's shading to the right. Or x has to be less than or equal to 4. Less than or equal to, so it's going to be a filled in circle, and it's going to the left. In this situation, we're saying that x could meet either one of these requirements. X could be greater than 9/4, so anything over here would be a solution. Anything from this point to the right is a solution. Or x could be less than or equal to 4, meaning that anything from this point right here, anything from that point to the left is a solution. And what ends up happening here is you basically end up with everything as a solution. Because, I mean, choose a number. Negative 1 million. That would work for this guy because negative 1 million is less than 4. Positive 1 million. Well, positive 1 million would work because it is greater than the 9/4, right? It's greater than 9/4. So really big numbers work, really small numbers work, and everything in between. It is going to be all values of x. The reason this happens is because you end up with these arrows kind of going in opposite directions here. Let me see. Opposite directions here, and there's a little bit of an overlap, but because of the word or, it allows us to have an answer of all values of x are solutions. If the word was and, it would be a different situation. But for this problem, it is all values of x. So let me go ahead and click that, and let's go ahead and do another problem. Here we have an and situation. So this is a different case than what we had before. Our solution is going to have to meet the restrictions of both inequalities. So let's go ahead and solve both inequalities separately. We have 3x minus 8 less than or equal to 23. And you add 8 to both sides. And you get 3x is less than or equal to 31. Divide both sides by 3. And we get x is less than or equal to 31 thirds. This other problem here, let's solve this inequality. Negative 4x plus 26 is greater than or equal to 6. Subtract 26 from both sides. Negative 4x is greater than or equal to 6 minus 26 is negative 20. Divide both sides by negative 4. And we get x, because we divided by a negative, make sure you flip your inequality. Now it's less than or equal to. Negative 20 divided by negative 4 is a positive 5. X is less than or equal to 5. And x is less than or equal to 31 thirds. I'm going to draw a number line here to help me visualize this for our x values. 5 would be, let's just say, well, 31 thirds is a more complicated one. 31 thirds, it's 10 and a remainder of 1, so 10 and a third. So I'll just put it over here. So this is 31 thirds, which is around 10. And visually in my head, I'm just like, it's about 10. So that means that 5 would have to be somewhere to the left. Again, spacing doesn't matter. I just want to visualize it. We have something that's about 10, 31 thirds, and 5. So x has to be less than or equal to 31 thirds. So it has to be less than or equal to 31 thirds. So it's going to the left, right? Because it has to be less than that. But we also have to have the solution here be over here as well. X is less than or equal to 5. And this is a case where it has to meet both parameters, meaning if x doesn't work for one of the inequalities, it's no good. So for example, 8. 8 would be a solution for this guy, but 8 would not work over here because 8 is not less than or equal to 5. 8 is greater than 5, right? So 8 is not a solution. But everything from 5 to the left is a solution. Because if I choose a number that's to the left of 5, let's just do 0. Is 0 less than 5? Yes. Is 0 less than 31 thirds? Yes. So everything to the left of 5 is going to be a solution to the inequality. But the things that are between 5 and 31 thirds, those are not going to meet both of the inequalities. They're only going to meet one of the inequalities. That's why we would say for this problem that it has to be less than or equal to 5. So x is less than or equal to 5. One of the hardest parts about these compound inequalities is every single problem is different. You can't just expect the same pattern to happen over and over again. It's just not one of those concepts in math. Let me go ahead and check my work. Looks like we got it right. So let's go ahead and do, let's see, 2 more problems together. You'll find with this, the solving of the problems is actually, probably pretty fluent by now. You guys have gotten pretty good at that. But it's the analyzing of your solution that is the hard part. The solving is the easy part. So we have negative 6x plus 14 is less than negative 28. If I subtract 14 from both sides, I get negative 6x is less than negative 42. So I divide both sides by negative 6. X, because I divided by a negative, make sure you flip your inequality. X is greater than, in this case, positive 7. Or the other inequality, 9x plus 15 is less than or equal to negative 12. Subtract 15 from both sides, and we have 9x is less than or equal to negative 12 minus 15 is negative 27. And I need to get x by itself, so I divide both sides by 9. X is less than or equal to negative 3. So here is our solution right here. It's these two problems here with the word or as well. So x has to either be greater than 7 or x has to be less than or equal to negative 3. We'll draw a quick number line here for our x values and plot our solution set. We have negative 3 is over here somewhere, and we have 7 over here somewhere. X has to be greater than 7, so an open circle shaded to the right, or x could be less than or equal to negative 3, filled in circle, shaded to the left. It can meet either one of these parameters, so it doesn't have to meet both. Like the last problem we had, where it had the word and, we needed to find a solution that met both of the parameters. That's not the case here. In this case, all it has to do is meet one of these two problems. So let's just think this through for a second. Anything that's in between is not going to work. Like let's just say 0. Well, 0 is not greater than 7, and 0 is not less than negative 3. So 0 is not going to work. Let's choose a number to the right of 7. 10. Is 10 greater than 7? Yes. So that's a solution. Even though it doesn't meet over here, because this word or is being used, it only has to meet one of the inequalities. So 10 would be a solution. What about negative 10 on this side? It doesn't meet this inequality. Negative 10 is not greater than 7. But it does meet the other inequality. Negative 10 is less than or equal to negative 3. So that works. This is the case where we end up with many solutions, but there are some things that are not solutions. So it can't be the all values are solutions. Only certain values are solutions. It's to the left of negative 3 or to the right of positive 7. It's this one right here. X has to be less than or equal to negative 3 or x has to be greater than 7. And we will do one more problem. I know it says that I already did the problem set, but let me go back and I'll do one more with you and hope for something different looking, just to continue learning different types of problems. Let me clear this out first, and we'll do one more. This time we have an and problem. So we have 3x minus 91 is greater than negative 87. If I add 91 to both sides, I get 3x is greater than positive 4. Divide both sides by 3, and I get a solution of x is greater than 4/3. I also need to solve the other inequality. 17x minus 16 is greater than 18. Add 16 to both sides, and we get 17x is greater than, when I add 16 to both sides, that ends up equaling 34. Divide both sides by 17, and you get x is greater than 2. All right? So the solving part is actually not too bad. But our challenge here is determining which of these is the correct solution. That's probably the most challenging part here. Not just answering this, but actually analyzing it. So x is greater than 4/3 and x is greater than 2. In this case, if I plot my number line here, let's see, for x values, and I'm trying to plot my solution set. Well, let's just say this is 2. 4/3 is 1, remainder 3, 1 1/3. So it's over here somewhere, 4/3. X has to be greater than 4/3, so x has to be bigger than 4/3. It's an open circle shaded to the right. And x has to be greater than 2. So open circle shaded to the right from 2. So numbers like 5 would work for both, right? Because 5 is greater than 4/3 and 5 is greater than 2. But what about the numbers that are in between 2 and 4/3? Obviously, negative numbers aren't going to be a solution because they're not even being shaded in our number line. But what about like 1.5, which is between these two? 1.5. 1.5 is greater than 4/3. Yes, 1.5, like somewhere in this area, is greater than 4/3. But it has the word and. So it is 1.5 greater than 2? It's not. Because the word and, it has to meet both inequalities. So that definitely changes the game. So this area of the number line is not part of the solution set. Only from 2 and above is it part of the solution set. So when we look at our answer choices here, it has to be greater than 2. So it's this guy right there. The challenge with this part of Khan Academy, or just this part of math, is that every single problem is different. And many times you're accustomed to the solving of the problem is the hard part. That's actually the easy part. The hard part is taking your answer and expressing it in a way that is more definitive. This is a good answer technically, I mean, that's not bad, but this is the correct answer. This is the best answer. All right, I'm gonna go ahead and end this video. If you need more help, you can always contact me.